Hello children, these are the remaining numericals of NCERT from chapter motion from question number 5 onwards. NCERT textual questions. A driver of a car traveling at this speed applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. So let us, for car A, what is the initial speed? It's 52 km per hour. This value, so we'll convert into meter per second. We'll multiply with 5 by 18. So it is 260 by 18. Okay. Similarly, this is meter per second. Now it stops. It means final velocity is 0 and time taken is 5 seconds. So we can plot. See what they have asked actually. We'll have to plot in the same graph paper speed versus time for the two cars. So I'm just telling you that let us draw it separately first, or let it be what is the value of this. We will cut and see. It will come equal to 18 ones are 18. Okay, so 8. It will come equal to this value. Okay. So somewhere here we take, let it be 14.4. So this is your velocity axis and this is your time axis. So it comes to rest in 5 seconds. So you can show it like this. Let it be 5 seconds. So this is your graph for first car. On the same graph paper, okay, another driver going at 3 km per hour applies his brakes and stops in 10 seconds. So let us note down the details. Car B, initial velocity is 3 km per hour. We'll convert into meter per second once again. 3 6 up. So it is 5 by 6. So it can be written as 6 7s are 42, 6 8s are 48. So it is approximately 0.8. Okay, you can divide it further also, but okay. So now it stops. So final velocity is 0 and the time taken is 10 seconds. You can see here 10 seconds. So now we'll have to draw. So initial velocity is 0.8. So graph will start from 0.8. 0.8 is very much low. Even you can show lower than this. This is 14. So this is 0.8. Let it be. And it takes 10 seconds. So 10 is here. So this is for car B. This is for car A. Proper graph can be drawn. Once again, let us see. Yes, children. So you can see in the second graph clearly. Here the blue line is representing car A's motion and this brown one is for car B. So this is velocities or speeds axis and this is time axis. First car's initial velocity is 14.4 meter per second. Second car is 0.8. It is taking 10 seconds to stop and this one is taking 5 seconds. Okay, so first job was to draw the graphs on the same paper. And what is the second question? Which of the two cars traveled farther after the brakes were applied? So, you can write this thing, that area of velocity time graph gives us displacement. It means which car goes farther can be told by looking at the displacement, which is calculated by area of the graph. So, we'll find out area of graph for car A. That is displacement of car A. So area is given by area of triangle. You can see this triangle I'm talking about. So it will be half base into perpendicular. Now what is the base? 0 and this is 5. So it is 5. That is 5 minus 0 is 5. And what is perpendicular? 14.4 minus 0, that is 14.4. So you can multiply 7.2 and 5. You will get dash, whichever value will come in meters. So that is the displacement traveled by graph A, car A. Similarly, you can find out the displacement of car B like this. This area we need to find out. So this is also a triangle. So you will write displacement by car B is equal to area of graph. Which graph? B, which is a triangle, area of triangle, which is equal to half base into height, that is perpendicular. So what is base? 0 and this is 10. So 10 minus 0, that is 10, and height is this much. This much is height, that is 0.8. So this is 0.4 and you can multiply, it's 4 meter. So this is 4 meter, and what is this value? 5 into 2 is 10. So it is 36. So its displacement is more and its displacement is less. So this is question number 5. Now we'll go to question number next. Okay children, so let us go to the next question. In this question, a graph is being given for 3, let us say car A, B and C. Okay, this is distance and time graph. Here it is distance in kilometer and this is time in hour. So you should see that A started from this point, B started from 0 and C started, this is C, it started from here. So initial position should be noted down very carefully. Okay. So first of all we will see this, that it is 4 kilometers, right? And up to here how many blocks are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7 blocks make 4 kilometers. Right. So 1 block will make 4 by 7 kilometers. This you will keep in mind. Okay. Let us see what is the first part of the question. Which of the three is traveling the fastest? So we know slope of the graph gives the speed. So we'll write it as we know slope of distance time graph gives the speed. So slope means the angle that it makes with x-axis. So check that angle. For example, here the angle is this. Right? Now similarly we can find out the slope for others. For example, this is making this much angle. Okay? And here angle is this. So whose angle is maximum? Clearly this angle is maximum. So its slope is maximum. So its speed is maximum. Which line is this? Whose line it is? B. So B is traveling fastest because its angle is maximum. That is its slope is maximum. That is its speed is maximum because speed is given by the slope of distance time graph. Getting to the next part. Are these three ever at the same point on the road? So let us see. Do they intersect? Are these lines intersecting at a point? No, there is no such point. So no, they don't meet. How far, this is third question, we all will understand very properly. How far has C travelled when B passes A? So when B passes A, so question is very nice. Let us see. This is better diagram. We can look here everyone. So when B passes C, where is B? this one red, C is blue. When B passes A, sorry, when B passes A, so here A is green. Okay? So green and red are intersecting here. How far C has traveled? This is the question. When B passes A, so how far C has traveled? This blue has traveled. So we will see they are meeting here. So we will put a perpendicular. Perpendicular is touching C here. So what is C's position here? We'll find out. Okay. So what is the position of C here? So you can see it is approximately equal to 8. Okay. In fact, it is equal to 8. Yeah. It is equal to 8. So where is C right now? Position of C is at 8. Okay. But what is their question? How far C has traveled? They are not asking where is C. How far it has traveled. So what is initial position of C? It's here. This is initial position of C. Initial position of C. So this is the initial position of C, C dash. This is 1 block, 2 block, 3 block, 4 block, and you already know that 1 block is 4 by 7. 7 blocks. Okay, so it is 4th block. So 4 into 4 by 7, that is 16 by 7 kilometer. This is initial position. 7 2s are 14. Okay, then approximately 7 3s are 21. 7 2s are 14. Yeah, 7 3s are 21. So this is initial position. And now where is it? Final position. This line, 8 kilometer. So how much has it come? Distance traveled. How far has it come? Yeah, what is your answer? So you will subtract 8 and 16 by 7. So you can take LCM and you can report the answer. This much it has traveled when this B meets A. So this is very important part. You can see it again to understand. So let us go to the next part of the question. Let us see what is the next part. How far B has traveled by the time it passes C. So B and C. B red, C blue. So they intersect here. Henna. So how far? I think C has traveled. B has traveled. So where is B right now? B is here. So how much it is? 1 block is 4 by 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay. And if you feel that they are intersecting here, then you can take this also. It is okay. But I can see here clearly that this is in 10. Okay. So where is he? Final position of B. It's either 9th or 10th. If it is clear to you. So 10 into 4 by 7 kilometers. So it is 40 by 7. Okay. And now this is final position. What is the initial position of red? It's 0. So you can subtract the 2. So this is the distance traveled by him, by B. So basically it is 40 by 7. See, in certain graphs we will see it as 9, so but that is also okay. If you feel they are intersecting here only, so no problem. Okay children, so let us see question number 7. A ball is gently dropped. So you know When a ball is gently dropped, then u is 0 meter per second. In case of throwing down, it is initial velocity 0, and when we throw up, final velocity 0. So this is height is 20 meters, or you can write it as S displacement 20 meters. If velocity increases uniformly at the rate of this, so check the unit, meter per second square. So this is acceleration. So what is the value? 10 meter per second square. With velocity, with what velocity will it strike the ground? So final velocity is to be calculated and time. So we have S, we have A, we have U, we have to find out V. So which equation does it contain? These all third equation of motion. Using third equation of motion. What is third equation of motion? Let us use V square minus U square is equal to 2AS. So we have V, U we have, that is 0 square, 2 into A into S. So you can see V square is 400 and V is 20 meter per second. Now we have to find time also, so we can use first equation of motion. V we have, U is 0, A is 10, so 20 is equal to 10t and time is equal to 2 seconds. So getting to the next numerical now, which is question number 8. So let us see this question, question number 8. Here the speed time graph for a car is given. This is speed time graph. We have to tell how far does the car travel, that is the distance in first 4 seconds. So first 4 seconds you can see. Okay. If you wish, you can find the area of the triangle, which is approximately equal to this area. This area is very small, so we can find out the area of the triangle. Okay. So you should write like this. Area of speed time graph. Slope gives acceleration and area gives displacement or distance. So we can consider it as triangle. So we can find out the distance or displacement. That is half base into perpendicular is displacement. So half, what is the base? 4 minus 0, that is 4. And what is perpendicular? This line, 6 minus 0. So you can see it is coming as 12 meters because it is distance. How far the car travels? 12 meters. Okay. Now coming to the second part, which a part of the graph represent uniform motion. So you can see in the graph from 6 to 10, it's a straight line. From approximately 6 to 10, it's a straight line. So you can say the from 6th second to 10th second. The graph is uniform and the graph is a straight line parallel to time axis and motion is uniform. So let us now look at the next question, which is we'll have to tell whether following situations are possible or not. If they are possible, we'll have to tell example. If these situations are possible. An object with constant acceleration but zero velocity. So yes, when we throw an object up, it reaches maximum height, it stops, velocity is 0. But acceleration is constant. Okay, that acceleration is due to earth, which is called acceleration due to gravity. So at highest point, for a moment, velocity is 0, but acceleration is constant. So there is a situation which is possible. Number 2, moving with acceleration but uniform speed, fixed speed. So yes, when the object moves in a circular path, then speed can be fixed like 15 meter per second everywhere, but velocity will change. Why? Because direction is changing. Direction in a circle is given by tangent. This is the direction here. Velocity is direction. Here at this point, this is the tangent. So this is velocity is direction. So direction of the object is changing. That is direction of velocity is changing. That is velocity is changing. So if velocity will change, then acceleration will be there. So yes, acceleration is there, but the body is moving with fixed speed, not velocity. So body can move with uniform speed, fixed speed, but acceleration would be there in circular paths. Okay. The body moves in a circular path with uniform speed, but still it is under acceleration because velocity keeps on changing. Why? Because direction is changing. So there is a situation which is possible in which direction is changing, there is velocity changing, that is there is acceleration, but it can still move with single speed. An object moving in a certain direction, acceleration in a perpendicular direction. So yes, for example, when we make an object move in circular path, then velocity is given along the tangent. So this is one direction of velocity, and acceleration acts toward the center along the radius. So velocity in one direction, acceleration is another direction. So yes, it is possible. Velocity in a particular direction and acceleration in another perpendicular direction. So yes, you can see here velocity in a circular path is shown by the tangent. This is velocity's direction, and acceleration is acting along the radius toward the center. So acceleration is in perpendicular direction. Velocity is along the tangent and acceleration is toward the center. So in a particular perpendicular direction. Getting to the last question of exercise. An artificial satellite is moving in a circular orbit of radius this. So radius is given 42250. Calculate speed, that is it. If it takes 24 hours, the time is 24 hours. So it is so simple. It's like speed is to be calculated. So distance of one revolution divided by time period. Time period is the time taken to complete one revolution. 24 hours to revolve around Earth. So what is the distance of one revolution? That is circumference. In one revolution, how much is the distance traveled? Circumference 2 pi radius divided by time period. So 2 pi we have, radius we have, and time period is given. So substitute and calculate and report in kilometer per hour. If you wish to report into SI unit, you will have to multiply with 5 by 18. Okay, otherwise you can report in kilometer per hour. Kindly prepare these numericals.